It is Monday morning, probably. Thank you for being patient while Miss McKibben and I shared some video files together. Monday, March 23rd, we're going to talk about evaluating piecewise functions. So basically, we're going to be doing some plug and chug. So if you don't have your calculator with you, you might want to pause the video real quick and grab your calculator and get that ready to go. Announcement. We will be having a mock test on Wednesday of this week, covering all the material that we started from last week. No, that won't go into your grade book. This is simply just to give you an idea, give us an idea of how well you are learning the material, how hard you've been working, and just to kind of keep ourselves, in the groove of learning material and having to be assessed on it. It will be given to you as a PDF on the blog. You'll have 8 hours to do it, anywhere from 11 a.m. to 7 p.m. on Wednesday, and you will either email me or send me a picture via Remind, your answers, and I will grade them, get it back to you. More details will be posted on the blog, either early Monday morning or sometime before office hours are over on Monday before 2 p.m. All right, so by now I'm hoping you have that calculator and you are ready to roll. Okay, so I am looking at problems that are on page 22 of your packet. A piecewise function is going to be a function that has 2 or 3 different pieces to it. So here you'll see you got one piece, and here's a different piece. When you get down to this problem, or these sets of problems down here, you've actually got 3 pieces that we need to look at. So 3 pieces of that function. All have what we call different domains. So basically that means that we will be using different sets of numbers for each different part of the function. And so as we look at that, I'm going to erase part of this. And we're going to look at this part right here. Let's turn that a different color. We're going to look at this part right here. Okay, this is what we're going to call the domain of the function. So this is where we're going to look to see which excuse me, which function, which part of the function we're going to use. Okay, so I'm gonna move that right up here. This is the domain. And so right here, let's see if we can get an arrow going. This set here, let's turn that around. We'll go start back here. This part of the function works for x values that are x values less, so greater than 4. I'll tell you what I'm going to do. I'm going to highlight that yellow because that goes with the yellow, the top part of the function. So this is going to, whoop, that is not yellow. Go back to yellow. Yellow. All right, so if you can think of some numbers that are greater than 4, we're talking about 5, 6, 7, 8. Who do you appreciate? Okay, so any of those numbers that are bigger than 4. 8, 9, 10, 11, 12, 13, 14, anything bigger than 4. So down here, on the bottom part, we're looking at x values that are less than 4. Well, let's put less than or equal to 4. And we'll make that blue or green because that matches what we're talking about. So what are some numbers that are less than or equal to 4? Well, 0, 1, 2, 3, and 4. So this part of the equation here, this part of the problem is going to tell you which numbers to plug into each one of these. And so let's take a look at a problem. And I'm going to use color coding here. So this, I thought I got it. I thought I had that one. This is the x right there. That's x. Okay. Let's get that up there. Okay, so our x is 7 in this problem number 1. Over here in problem number 2, our x is 4. And over here in problem number 3, our x is -3. So I'm going to use our highlighter, either green or yellow right here. And I'm going to highlight the 7, the 4, or the 3 to match which part of the function it goes into. Now, where do we make that determination? We make that determination in here, in the domain. So we ask ourselves this little question. Is 7 greater, or let's do this. How does 7 compare to 4? So is it greater than 4, or is it less than or equal to 4? Well, I'm hoping you're all saying, yelling at the screen, it's greater, it's greater. Okay, so 7 is, this part of the function here, it works for values that are greater than 4. Okay, so let's take a look at this one right here. I'm just going to copy this. How does 4 compare to 4? I think it's equal. I hope you guys are saying that it is equal to 4. So this part of the domain right here says that it works for x values that are less than or equal to the value 4. So that is going to be green. Okay, one more time. Grab this, copy it, put it over here. How does -3 compare to 4? Pretty sure it's still less than, okay? So we'll use our green highlighter right here. We'll say, all right, -3 is less. So now we take these numbers, 7, 4, and -3, and we put it into its respective part of the function. This is the plug and chug part. This is where you'll use your calculator. So we'll use the yellow part here for number 1. The 7 is the x value that goes in place of x. X will disappear. It's going to look like this. 3, parentheses, 7, minus 5. Make that just a little bit smaller. Okay, now it's our job to evaluate that. In other words, grab your calculator, make the calculation. This is 3 times 7, which will be 21. We'll take 5 away. So that equals 16, and that is our answer. That is the evaluation of 7 in that function. So that's our answer right there. Okay, second problem right here. I'm going to take this 4. We're going to plug it into the green part of the function right here, because earlier we decided that the x value, which is 4, is less than or equal to 4. So this function is 4 squared. Oh boy. There we go. We'll do it that way. Make this a little smaller. And I think you all should still be able to say that that is 16. So I'm going to highlight that in green. Here it is. That's our answer. Right there. Make that green too. Make this one yellow. And we got one more over here to work on. So how does -3 compare to 4? Well, it is less. So we use this less than function over here, which is x squared. So we take the function, which is something squared. Our something is -3. We're going to raise that to the second power. You guys hopefully will get 9. Because anything squared is positive, and 3 squared is 9. So we get another answer over here of 9. All right. So now it's just a matter of looking at more problems. That is the explanation. You use the domain to figure out which part of the function to put it in. So we're going to scoot down a little bit and do some more of that same thing. So now we have 3 different parts of the function. 3 different parts of the domain right here. This is the domain. Oh, right here. Let's go with red. Okay, here's the domain. This is where we make our decision. All right, 10. Okay, 10. Is 10 less than or equal to 1? No. 10. Is 10 less than 3? No. Is 10 10 greater or equal to 3? Yes, it is. So let's just grab the blue highlighter real quick. Boom. We're going blue with that one. Here in the middle. 2. Is 2 less than or equal to 1? No, it's not. 2. Is 2 less than 3? Yes, it is. So we're going to use the green part for number 5. Okay, last one. Over here, number 6. 0. Is 0 less than or equal to 1? Yes. Yes, it is. 0 is less than or equal to 1. So we'll use the yellow part for that part of the function. And now it's a matter of calculating, plugging and chugging. So we use the blue one. Use blue here. So it is 6 minus 2 times 10. So 6 minus 20, -14. In the middle, 2. We're going to plug 2 into this. Oh, wait, there's no x. How can you plug 2 into a 3? You can't. So we take the 2 and we say, well, you can't plug it in there. So therefore, this 3 becomes the answer. 3 is the answer. As I highlight that, it's probably going to disappear. Bye-bye, 3. Okay, we'll try that. Try just a different way to circle that. There was no way for us to plug a 2 into this. So the value that is there becomes the answer. That 3 comes directly from right there. All right, third one over here. Okay, 0. 0 into this top function right here. So that is -2. I'm going to draw the absolute value bar. It's probably not big enough. All right. 0 plus 1. That works. Okay. So PEMDAS says we're going to do everything inside the absolute value bar first. So it's going to bring us to -2. Absolute value. 0 plus 1. Well, that would be 1. And now this becomes, well, what is the absolute value of 1? Well, that will be 1. And so our final evaluation of that is -2. Oop, wrong color. Gotta go with yellow. Okay. So I'm just going to do some more problems with you. On page 27, a few more problems. We've got two different problems, basically. We've got two different functions. So let's highlight these just so you have an idea. We got x plus 5, and we got -4. Our domain for this set of problems is right here. We compare it to 2 or to -2 right here. So you're either bigger than -2 or less than -2, or you're equal to -2. Okay, let's see. Grab our highlighters. Okay, 3 right here, 3. Is 3 less than or equal to -2? No, it's not. Is 3 greater than or equal to -2? Well, yes, it is. So the 3 gets plugged into the bottom. All right here. -4. Is -4 less than -2? Why, yes, it is. So that's going into the yellow part of the function. Over here on the right, -2. -2, is it less than -2? No, it's not. Is it greater or equal to -2? Yes, it is. So that one's going green. So over here, how do you plug -3 into -4? You don't. So that answer is -4. -4 into the top becomes -4 plus 5, which equals 1. And over here on the right, -2 goes into the bottom function. Can't actually put anything into the bottom function, so therefore, once again, the answer becomes -4. So anything that would have gone into this bottom function is going to answer out at -4. All right, 3 more, and you're on your own. Let's use a couple different colors this time. We use blue and purple. All right, domain this time revolves around +1. Okay, -2. Is -2 less than 1? Yes, it is. So -2 will go into the blue function. 6. Is 6 less than 1? No, it's not. Is 6 greater or equal to 1? Yes, it is. So 6 goes into the purple function. All right, 1. Is 1 less than 1? No, it is not. 1. Is 1 greater or equal to 1? Yes, it is. So it also goes into the purple function. So now we know where to put them. Let's plug them in and chug and get some answers. All right, so -2 goes into the blue function. So -2 parentheses. I'm sorry, I wrote that wrong. 2 parentheses, -2 goes inside the parentheses, plus 1. So that is -4 plus 1. It's going to be -3 as an answer. All right, on to the purple part. 6. All right, so we're going into this bottom function. That's -2 parentheses 6 close parentheses plus 3. So -2 times 6 is 12. It's -12. -12 plus 3 is -9. So -9 becomes our evaluation. Okay, that's our answer. 1. It's also going into the purple. So -2 parentheses 1, close it, add 3. That's -2 plus 3. That's just a good old 1. And we have our evaluation. There's our answer. Okay. All right. So that is evaluating piecewise functions. Look for the domain. The domain is going to tell you which part of the equation to plug it into. The number that's inside the parentheses is your x value right here. And at that point, you're plugging and chugging. 7 goes into the x value. 3 times 7, 21, minus 5, 16. So your plugging and chugging once you decide which function to plug it into. All right, so here's a little recap of what's coming up. Tuesday, tomorrow, is going to be a review day for you. We have a mock test on Monday. On Wednesday. You have 8 hours to complete that test. You will have opportunity before 11 a.m. on Wednesday to ask me questions. Once 11 a.m. comes on Wednesday and the test begins, you cannot ask me any questions. I will not answer you. You are to submit that test via Remind. You can send me a picture. You can send it to me through email. You can scan it and send it to me. Take a picture of it and send it to me. It is not going into the grade book. It is simply to see how you're doing and trying to understand what's going on. Tonight's homework or Monday's assignment are 15 evaluating problems, just like we did. They are in Delta Math, so it will give you immediate feedback. Once again, we have office hours from Monday to Friday, 11 a.m. to 12 p.m., and then 1 p.m. to 2 p.m. You guys should take advantage of those. Not too many people are. Good luck with this, and I look forward to hearing from you. Have a great day, guys.